Hi everyone, we're Jackie, Nikhil, and Prakul. Today we're going to present Swift Rescue. Floods have a massive destructive effect across the globe. They're the leading cause of weather-related deaths. Every year, floods cost over $200 billion in damage. And hitting close to home, Texas actually has the highest number of fatalities from flooding across states. Floods also result in staggering levels of carbon emissions, with 25 billion kilograms of carbon dioxide every year. With the global and environmental devastation caused by floods, we created Swift Rescue.
And that leads into our value proposition. With Swift Rescue, we're both pre-disaster preparation and post-disaster relief. We have a flood forecasting AI and ML engine for prediction, our real-time communication network, and carbon-sensitive vehicle route optimization software for rescue and relief. And finally, our social media feed for people to stay aware about climate change. Now we have a quick demo of our product. So let's take an example scenario. This is our dashboard, and let's look up New York. In New York, our model has predicted 1 to 3 days in advance with 97% accuracy that there is going to be 2 floods. Using Swift Rescue, first responders can now prepare ahead of time and scan for metrics using our other dashboard. So next, we made a real-time communication network that connects victims to first responders and the other way as well. Back to the scenario, the flood is now hit and some people are unfortunately struck or injured. Using our app, people can see other victims in the area and directly reach out to responders for resources and help. They can also leave notes for other people to read. Finally, we made a vehicle route optimization software that can find the most optimal carbon-efficient path between various post-disaster relief stops. So in this scenario, the flood is now passed, but rescue efforts are still underway. Using Swift Rescue, responders can take the most efficient paths between victims and resource centers and deliver resources. Afterwards, people affected by the flood can stay up to date on climate information and events by using our feed, which is specifically tailored to the area that they're in. Here's a quick architecture diagram. Our flood forecasting engine ties into Firebase, which ties into our front end and sends it flood alerts as well as other location and user data. And then we have a route optimization API, which sends shortest path information to the front end for view and visibility.
So going into a bit more depth about each of these components, starting with the flood forecasting AI engine, let's see how it works. So we use the NOAA storm dataset to get a list of past floods and clean and cross-reference those dates and locations with 5 other datasets ranging from iMerge precipitation 1 to 3 days before each event to a global lithology map. We then clean and process over 100 gigabytes of this data into 6 distinct features, compile that into a single dataset, and trained random forest models on that data, ending up with 97% accuracy in predicting floods 1 to 3 days in advance. Now, another important question to answer is the question of if a flood does happen, how severe would the damage potentially be in a certain area? And to answer this question, and in answering this question is important because it helps first responders pre-allocate resources to those areas before the floods occur. And so we built this susceptibility map by combining the random forest feature importances after the model was trained with the static features from the dataset that we compiled. And so we got a measure of the terrain susceptibility independent of time. So now talking about route optimization, we did this by simulating population clusters based on real population data, and then used a combination of k-means to cluster those users and a nearest neighbor solution to Dijkstra's, a nearest neighbor solution to the traveling salesman problem to get a list of contiguous paths representing the optimized route, which would be helpful for like aerial delivery of packages and rescue and recovery. And here's our tech stack and the technologies that we used. Thank you so much for your time.